Hello everyone, I'm Sachin and I'm presenting my CSE 564 final project, US County Health Inequality Dashboard. The goal of this project is to explore how different socioeconomic, environmental, healthcare, and demographic factors relate to poor health outcomes across US counties. For this project, I built an interactive single screen visual analytics dashboard with no scrolling elements and all plots visible at all times. So to answer my question of how does this socioeconomics and environmental factors relate to poor health outcomes, I have collected data sets from different domains such as county health rankings, National Center for Health Statistics, American Communities Surveys, and I have merged all of these data sets using FIPS as the common identifier. Now, this data set contains 3,159 US counties and has variables from different domains such as we have variables, geographical identifier variables such as FIPS, state, and county. And then we have health outcome variables such as fair or poor health, which says the percentage of adults that report poor health, and life expectancy, child mortality rate, infant mortality rate. And then we have health access and environmental variables such as access to access opportunities, food environment index, primary care physician ratio, uninsured rate, and average daily PM 2.5, which is the pollution well. And then we have socioeconomic variables such as the percentage of adults who have done college or high school or still unemployed, and the median household income and population. So coming back to the dashboard, we have five main panels. We have a US county cluster chloropeth, a ridge regression coefficient, MDS projection, cushion tree map, and parallel coordinates plots. So coming to the first visualization, which is the US county cluster chloropeth. So I have each county is a data point from our data set. So I have used the k-means on this the numerical variables of this data set to classify these counties into clusters. And using the elbow method, we found that five clusters is the optimal number of clusters in our case. So I have used k-means to classify all of these counties into five clusters. Now, the chloroplet map reveals some interesting patterns which are difficult to see in a table. So we can see that the counties in the north are concentrated to be in cluster 1, and the counties in the bottom are concentrated to be in cluster 4, which gives an intuition that ge- geographical area can influence the socioeconomic and environmental variables. And coming to the second visualization. So since I'm focusing on the poor health outcomes, I have used the poor health variable as a target, and I wanted to check how much does each other variable has a predictive power on this variable. So I trained a ridge regression model taking all other numerical variables as inputs, and I'm predicting the poor health variable. And I've collected the weights of each other variable, and I use them as h- how much these variables have can predict the poor health outcome. I have used ridge regression instead of ordinary linear regression because many of these variables are correlated. For example, income, education, or insurance, and even life expectancy are likely connected. So ridge regression helps stabilize these coefficients when predictors overlap. And also, before fitting the model, these predictors are standardized. This is important because all variables have different units and different orders of values. So standardization make these coefficients more comparable. And this diverging bar chart shows which variables are associated with higher or lower poor health. The blue bars on left represent negative coefficients, which means these variables are associated with lower poor health rates, meaning better health outcomes. whereas the red bars are associated on the right have positive coefficients, which means they are associated with higher poor health rates, which means worse, worse health outcomes. From this chart, we can see that completing high school has one of the strongest negative coefficients. This says that counties with higher high school completion rates tend to have lower poor health rates. And next, life expectancy also has strong negative coefficient, which makes sense because counties with higher life expectancy generally report better health. And food environment index also has negative coefficient, meaning better food environments are associated with lower poor health rates. Same can be applied for college and median household income. On the positive side, we can see that unemployment has a positive coefficient. Counties with higher unemployment tend to have higher poor health rates. And a- average PM daily PM 2.5, which is pollution, suggesting that air pollution may be associated with worse health. And similar logic can be applied for child mortality rate and uninsured rate. But I want to make a note that this this experiment does not prove causation. It is just showing association and predictive importance. This model just helps identify which variables are most strongly related to the poor health in this dataset. And now we come to the third visualization, the multidimensional scaling of data. So this visualization supports the first visualization that uh, the the clusters which o- the orange clusters and the blue clusters are uh, ap- far from each other, which means they have different social, economic, and environmental factors. And this also means that these change over the geographical area. And next we have cushion tree map. So for I made this cushion tree map because from the choropleth map we can see the geographical area, but area does not give us all the information. For example, if we see a big county and see a uh, poor health rate, that we cannot get full information because we don't know if there are many people living in that county or it's just one uh, few people with poor health. But using cushion tree map with population as the size of the county, you can see that a huge box rep- with poor health gives the attention that this county has huge population with poor health and needs immediate attention. So having cushion tree maps is very useful in these cases to find counties which need immediate attention. And then we have parallel coordinates plot, which uh, which plots the multivariate visualization of all variables, all numerical variables in this dataset. Because the categorical variables here are the state and county, which need not does not have much importance in this plot. This I also used edge bundling in this parallel coordinates plot to have a better smoothing curves and to get a better idea of what clusters have uh, are concentrated on what values. For example, you can see that the red and orange, which are cluster 2 and cluster 4, have a higher poor health rate compared to cluster 1 and cluster 5. So which says that the top the north counties have lower poor health or better health than the counties the south counties. Now for the interactive interaction of this data dashboard, I have added many features. Coming to the first one, I have added brushing and linking to the county cluster club. You can drag and you can select certain set of uh, counties, and all of the uh, other plots will be recalculated on the data points which are selected. So even the rich regression model will be retrained on the data points selected from this map. And by doing clear selection, you can go back to the original one. And uh, similar brushing effect can is also applied on MDS plot. You can select few few values, and you can see the corresponding counties being selected, and all the data will be all the plots will be recalculated from these data points. And for the interaction part in parallel coordinates plot, I have made made it possible that we can drag and reorder the axis of this parallel coordinates plot. So if you want to check the correlation between two different variables, you can place them next to each other and see how they are, like, do they have a positive or negative, or how do they have any correlation at all. So in conclusion, this dashboard provide a visual analytics approach to understanding county level health inequality in United States. So from this dashboard, we found that the poor health outcomes are mostly has geographical patterns, whereas the north counties have less, better he, he, uh, health reporting values than the south counties. And from the second visualization, we found some variables which positively contribute to the health reporting value, and variables which negatively contribute to the health reporting value. And we can find any urgent um counties which need immediate attention. Like for example, this Hidalgo County has a good population with very poor health. So this uh, visualization can help the find counties which has a huge, like, significant population with uh, poor health to focus on. Thank you, guys.